All right, everybody, we are Team 3343, and this is our project, the Hemodynamics Calculator for the Emory University School of Medicine.
Imagine that you're working in the cardiac ICU of a hospital where you see many patients. Several times throughout the day, you collect measurements from each of these patients and then write them down on a whiteboard or a sheet of paper. Then you open up your spreadsheet or online calculator and input those measurements to calculate critical hemodynamic values. Together with past calculations, this information is used to determine the appropriate dosage of medication to administer. Not only is this an outdated solution, it's inefficient, repetitive, unreliable, and prone to error. Our client is Dr. Rebecca Steinberg, who is a physician working at the Emory University School of Medicine. When she proposed the idea for this project, she was primarily looking for a way to make it easier to calculate hemodynamic values. We were surprised that there were no current solutions and soon learned that it would be helpful to also keep track of patient data to recognize trends, which help determine the appropriate dosage of medication to administer.
The problem we're trying to resolve focuses around five main pillars. The first one being that hemodynamics calculations are error-prone and time-consuming. The current process relies on handwriting calculations and erasing it with the whiteboard. Our project hopes to have an incredible impact on patient health, being able to save that data quickly and transcribe it instantaneously. There's a huge risk of inaccurate scores that pose risk to both patients and doctors involved. And there's a very big requirement for user-friendly interface, as this is a time-sensitive operation, which we hope to resolve.
So our intended users are our client, which are Emory Intensive Cardiac Unit clinicians. So just to build a quick profile, which is relevant to our product, our clients are experienced in their fields and have a deep understanding of hemodynamics. They are really well educated with at least 2 university degrees, and they're all fairly familiar with technology and computers and navigating web applications. Many clinicians currently depend on other computer systems, such as Excel sheets, to perform important calculations. And in fact, over 75% of our clients perform calculations 3 or more times a day. So we see a clear demand for our product in this area. So we surveyed 8 ICU physicians, and this is what they want. So essentially, they all want to remove room for error in all calculations, and all respondents currently use a handwritten process, and they want to reduce room for error in these handwritten calculations. 100% of survey responses also want the ability to view trends. When they write down measurements, they want to have a producible track record of these measurements and calculations. Currently, MD-Calc is an existing online medical calculator, which is used by at least 87% of all survey respondents. The survey respondents say that it's really easy to use and provides centralized locations for calculations, which makes it very convenient for ICU clinicians. There's a similar sentiment expressed about the Excel methods, but we are proposing our alternative solution via our product to act as an improvement over MD-Calc. So essentially what our product does better is that it's specialized for cardiac ICU use. It allows for the creation of patient profiles and being able to save these calculations to enable for this producible track record, and it allows the ability to inspect trends.
During our first sprint and also going forward throughout our development, we hope to adapt an agile approach or methodology. Some of the key aspects of Agile that we hope to really focus in on are a user-centric approach, which we've already done by going through a lo-fi prototype phase and a maze testing phase, and we have made sure to keep frequent communications with our client. We also really invested in a front-end, back-end split. We currently have our team divided into 2 halves in which we are able to have collaborative design meetings, but also split meetings where we can separate tasks and divvy up time more effectively. We're also really focused on version control and documentation through GitHub.
So let's take a minute before our artifact demo to discuss the tech stack we used for this project and why we chose it compared to other stacks. For the hemodynamics calculator, we chose the MERN stack. And while MERN's already vetted for being a reliable and easily implementable tech stack, it had major benefits over other stacks for this project. First, MongoDB allows us to have a deployed development database. This means that when we implement later MMFs that require patient data, we can create dummy patients that persist in our system so that we don't have to create new patients each time we start the application or hard code post statements into our source code. Because this is going to be a multi-page application, Express.js has obvious benefits. The Express layer of our app allows us to easily define routes in our application, specifically for our Node.js backend. And React offers state-of-the-art UI implementations, especially with the existence of libraries such as Bootstrap, which will allow us to develop our UI to the expectations of our users. Familiarity and connection between buttons and their functionality or expected web page layouts are easily implementable with React. So why this over the mean stack where we could use Angular instead? Well, to put it simply, Angular offers really advanced and complex front-end functionalities, and it's just not required for this project. By choosing React, we are actively removing an otherwise overly complex tech stack because at its heart, this is a calculator with a database connected to it. So Angular, although great, simply overshoots our needs and to overcomplicate the development process. Finally, Node. Node is a highly reliable framework that works easily with connecting a Mongo database specifically to a React or Angular front end. And since coming into this project, we knew that we needed a deployable database for development, and we wanted to remove the complexity of Angular, and this was going to be an app used mostly on desktops and laptops. Mern was an obvious choice for a tech stack.
All right, let's start our artifact demo. So first we need to start the server by typing node server.js in our server directory, as well as npm start in our client directory. And we can see that our application will start. First, you're presented with the patient list. This is where all of the patients and their data will be listed. We have our side nav bar on the left, which is all of the pages we will eventually implement in our project. So we can create a patient at the top right by clicking on Create Patient. You can see there's different input fields, so we can input their initials, a date of birth. These are all React components. We can assign them a sex. We can assign them a height in centimeters, a weight in kilograms, and then a medication from a preset list, which is going to be determined by our client. And so we can also add other notes. So for this person, let's say they last medication change on 11/20. We can then create that patient profile, and we can see our patient is populated in the patient list. If we want to change something about this patient, we can click the Edit button. We can change up these in any of the input fields. So let's say we input our date of birth wrong, and now we want it to be 12/12/2002. Let's say they're actually a female, 120, 121, or maybe 101, and then medication A, we update that record, and that is reflected in our patient list. So we can also delete our patient manually from our list once they leave the cardiac ICU simply by clicking delete.
So let's take a look at the lessons that we've learned from this semester. From our research and discussions with our client, we realized that this application is not just a normal calculator, as this necessarily doesn't solve our problem. Creating a patient system that can allow clinicians to record, track, and analyze data in an error-free format will provide our clients with a successful product. From actually building and working on our product, our process, we've worked consistently with an agile approach where front end and back end halves are assigned basic tasks each sprint. This proved very effective in our first sprint during this first semester. However, we did run into a small hiccup where the front end team had to wait for the back end team to catch up and finish their work before they could start working on their own stuff. So moving forward, we learned that collaboration and communication about what features each team is working on will help resolve issues where one team potentially gets ahead of the other and creating backlog. From our actual product that we've built, we're very proud of it. However, we understand that both user experience and functionality go hand in hand. We want to create a product that both A, is of course functional, and B, looks very nice and is very easy for clinicians in the ICU to use.